Hey guys, welcome back to another video. So here we'll be looking to do a complete breakthrough of the Core Maths C2 paper, and this is from the May or June 2018 series. Now, I already gone ahead and completed this whole paper, and I just want to say that overall, this paper was actually not too bad. I would actually rank it as one of the easiest papers from the last 5 years, in my personal opinion. I mean, everyone's got their own opinion, but in my opinion, I believe that overall the questions are not too bad. Most of them are asked in a very straightforward manner, and there's pretty much no difficult question here. There's only 9, so there's no actual hard differentiation problem. And overall, most of the questions are just generic and straightforward. But anyway, without further ado, let's just go down straight to the questions and start with number 1. So it says here that figure 1 shows a sketch of part of a curve of this equation here. Okay, so the equation is given and it represents this curve over here. So the finite region R shown shaded in figure 1 is bounded by the curve, the x-axis, and the line of equation x equals 10. So in other words, x equals 10, x-axis and the curve. So yeah, that seems okay. Now, so the table shows the corresponding values for x and y for the equation given. Complete a table giving values of y corresponding to x equals 2 and 6. Alright, this one is of course dead easy. It's only worth a mark, so you just essentially plug it in x equals 2 to this equation and finding a value for y, and x equals 6. Now, it doesn't actually state to give you answers in exact form or otherwise, so I'd assume you can do both. But because they actually did exact form for one of them, I think it's probably a good idea to actually find the exact form for them if possible. So what I did, I just tested on the calculator. When x is 2, thankfully you get a whole number, so the answer here would actually just be 2. But for when x is 6, you end up getting a sort of non-recurring decimal. And what this means is that it's probably best to evaluate it separately. So what I did, I just worked out, so of course 6 plus 2 is 8, and then in the calculator, I just took out this the square root value and just pretty much wrote root 8. And I decided, let me convert root 8 in my calculator, so plug this in the calculator, root 8, and you should get 2 root 2. And then cube each term. So the cube root of 2 is 8, and the cube root 2, well, I just wrote it as 3 consecutive root 2's. And one thing to note is that when you have 2 of the same roots, these two become a whole number, so these two become a 2. So essentially you got 8 times 2 over 4, which is 4, and then root 2 left, so 4 root 2. But yeah, if you guys already know how to do this, that's great. And again, this is 1 mark, so I don't know if this is necessary, but no big deal. Anyway, part B. Use the trapezium rule with all the values of y from the complete table to find the approximate value for the area of R. So same procedure, same story. And you're given the trapezium rule in the formula booklet, so that's good. But anyway, what I did here, I always do it my own way. I always let, for example, the region be approximately equal to h over 2, where h is the width, by the way. And to calculate the width very easily, just find the difference between each x value. In other words, a common difference. So you can see it's going up in blocks of 4s. Because minus 2 and 2 has a width of 4, this has a width of 4, and 6 and 10 has a width of 4. So h is more or less 4. Now, the formula is always the first y value plus the last y value plus 2 times everything in between. So the first and last y values, according to the table, would be 0 and 6 root 3. And then these two values in the middle are inside the middle parts. So this would be the 2 times the middle values. And that's it, just plug everything in, smash into your calculator, and voila, 51.412. So yeah, not much to say here, guys. This is a very straightforward trapezium question. There is no additional problem, and that's what there is. So if you guys have enjoyed it, if you guys have been enjoying this video so far, give me a like, subscribe, share with your friends. Otherwise, let's move on. Find the first 4 terms in ascending powers of x of the binomial expansion of 2 plus kx to the power 7. Now, the formula book actually has this already given, so it tells you how to expand it in at least 3 different ways. Now, the way I'm going to personally do it, and this is the way I like it, is to always rewrite this form in the general 1 plus ax form. In the formula book, it's written as 1 plus x to the power n, and it shows you how to expand it. If you're going to adapt this method, replace x with, in your mind, ax, and copy the formula down. But anyway, this is how the general expansion looks like. It's always 1 plus and then the power times ax, and then that's the next term, plus n times 1 value back over 2 factorial, because there's 2 terms now, times ax to the power 2, and so on. Then you've got 3 terms of 3 factorial, ax to the power 3, and so on. So that's okay. Now this one wants the first 4 terms, so we're looking up to the cube terms, okay? Now, to easily sort this out, the trick is to always factorize the 2 out. So to write as a 1 plus form, if you take the 2 out, it'll be 2 out the bracket. And because this is all power to 7, remember to take 2 power 7 out. And you're left with 1 plus and then kx, because you took 2 out, divided by 2, all to power 7. Okay, if you're not sure why you take the 7 out, just ignore this power 7 for a second. Imagine you just had like one big bracket again with 2 plus kx all to the power 7, right? If you factorize the inside, you literally just take 2 out, so you got 2 bracket 1 plus kx over 2 all to power 7, and then you just distribute the 7 to the 2 and the bracket, and that's it. Anyway, that's fine. So now let's go ahead and expand using our method. So far we got this. Now we want to expand only this bit, yeah? And by doing that, we're going to follow the method above. So again, it's always going to be 1 plus and then 7 times the ax bar, which is kx over 2. So so this is the first term and this is the second term. Now for the second power, it's going to be n times n minus 1, so 7 times 6 or 1 back, over 2 factorial times the ax bit, power 2, and then the next one, the same thing, but 1 down, so 7 times 6 times 5, over 3 factorial, because it's 3 terms, times ax to power 3. And that's it. That's literally 4 terms done. Now simplify all of this one inside the bracket. You know, literally just put this in your calculator, each term one at a time, including the squared and cube values here. So for example, if you want to work out this one quickly, at least this one here, you will type all of this side in the calculator and you write times, ignore the kx, imagine it's 1, so it'll be 1 over 2 cubed, and that'll give us exactly 35 over 8. And then if you're going to put the letters back, make sure you put k cubed and x cubed, and so on, k squared, x squared, and so on. And lastly, just times everything by now 2 to the power 7. And doing that, you should get this final expansion here. So if you guys have understood this, you know, just let me know. If there's another way, I mean, if you guys find a faster way or even a way you guys might even prefer, let me know as well. Anyway, let's move on to B. So given that the coefficient of x cubed in this expansion is 1890, find the value k. Now coefficient, guys, if you don't really know, is just literally the value in front of the x, or in this case x cubed. So if you look at this equation here, the coefficient of x cubed is 560k cubed. Coefficient just means the term in front of x cubed. Now it is telling us that this expression here is equivalent to 1890. So all you're essentially going to do is equate them and literally solve for k. So I did that over here. I just divided 560 across, cube root, and voila, k is 1.5 or 3 over 2. Okay, number 3. Oof. Alright, so this question, in my opinion, was probably the easiest question in the paper actually. And I'm telling you, it was really straightforward because there's not really much you're doing here. It's just very, very basic algebra. So anyway, well, let's have a look. What do we have here? So it says here that we got a function which is a cubic function where a and b are constants, and it tells us now, and this is the important bit, when fx is divided by 2x minus 1, the remainder is 30. In other words, the solution to this one, the function equals 30 when you plug in a certain x value. Now, when you have a linear term like this, remember to always equate to 0 and find what the actual x value is. So 2x minus 1 is 0, 2x is 1, and x is half. So all it's saying is literally plug in x is half into this equation and equate to 30. And that's what I did here. So this is the opening statement, and this is what you have to do. Now just literally multiply. So I just put this in my calculator. So I put 24 times half to the power 3 minus 3 times half, and it gave me 3 over 2. Half to the power 2 is a quarter, so a over 4, and you still got b. And then just rearrange it nicely. I just subtracted 3 over 2 across, so 30 minus 3 over 2. And then I multiplied the whole equation by 4, and I got this nice simple expression here. And that's exactly what they want. A plus 4b equals 114. So yeah. Now b is also similar. It says here that given also that x plus 1 is a factor for fx. Now pay attention to the words. When something is a factor, it means that the solution will be set to equal 0. Okay, that's what it means. In other words, the first equation was set to equal 30 because there's still a remainder of 30 above. In this case, it's a perfect fit. When something's a perfect fit, it means the equation is set to 0. Now, like the first one, it says x plus 1. This means that you're going to use x equals minus 1. Because remember, equate this is 0 and x is negative 1. So this is the value we're going to plug into the first equation, to the function, and solve when the equation is 0. So basically that's what I did. F minus 1 is 0, plug in x equals minus 1 to this equation, simplify this, and you should get something like this. Minus 21 plus a plus b equals 0, and finally a plus b is 21. So there's nothing you can do there. That's what they want you to do, I think. Yeah, find another equation. Now for C, it's just continuation A and B. Now you just have to solve the simultaneous pair of equations from part A and part B. So looking at C, we have 4a plus 4b and a plus b equals some values. Just make it easy. I just subtracted the equation and it gave me 3b equals 93. Divide by 3 and you get your value for b. And then just plug in your value b to any of these equations to get a. And I got minus 10. That's it. Like I said, this is an easy question. And and honestly, this paper overall was pretty good. I mean, if you guys did well, then seriously, you deserve it. Now, D. Hence, find a quadratic factor fx. So, if you think about this, the only time we get a quadratic factor from a cubic is that if we use long division and we divide it by a known factor like x plus 1. So, this one I didn't solve yet. I was hoping to do this to you guys. So essentially, you just want to do x plus 1 into this cubic term and then find the solution at the top, and that would be your quadratic factor. Now, let's see how we do this. So the first step is to ask yourself, how many times does the first x value fit into 24x cubed? And you can see if you divided x by this, you get 24x squared. So that's done. Now what we do is to do 24x squared times x plus 1. And this will give us 24x cubed plus 24x squared. Now that's what you do. Now here we're going to subtract these pairs. So subtracting the 24x cubed, well, you get 0, and that's objective. You're always supposed to get 0 here. Next, you do minus 10x squared, subtract 24 x cubed, x squared, and you should get minus 34. And now drop this down, because this is just long division, and then repeat the procedure. Now we ask ourselves, how many times does x fit into minus 34x squared? Again, just divide them and you're left with minus 34x. So just drop the power down by 1. And again, times minus 34x by x plus 1. So you always repeat that and you get minus 34x squared minus 34x. Okay, and just subtract. Again, this side gives you 0, so minus 3 minus 34. If you're not sure, I mean, I sometimes use a calculator, because you got to write literally in a calculator minus 3 minus 34. And this should give us a nice 31x. And then drop the 31 down, plus 31. And you can kind of see that you're going to get a remainder 0 soon. So again, how many times x going to 31x? Well, it goes exactly plus 31 times 31 with x plus 1, and you get the exact same expression. And that's it. And you get a remainder of 0. And that's perfect, because that's what this means is a factor, and we already know x plus 1 is a factor. And that means our, what's it called, our quadratic solution is going to be, a quadratic factor is 24x squared minus 34x plus 31. And that's it. All done. Alright, number 4, guys. Let's check this out. So figure 2 shows a flag x, y, w, z, x, so the whole shape around. And the flag consists of a triangle on the left side and a sector over here. Okay, with radius 5 centimeters up and across. So just think of this part at point y as the center of a circle, yeah? So the radius is here and here. So both of these have radius of 5 centimeters. Okay? So, next bit. The angle of the sector, angle ZYW, is 0.7 radian. So make sure you switch your calculator right now to radian modes to avoid any little mistake here. The points x, y, and w lie on a straight line with xy being over here 7 and yw being 5. Okay, this is actually a super easy question, by the way. Very super easy question. Now, A, B, and C. Firstly, A. The area of the sector. Find the area of the sector ZYW. So the area of the sector is, of course, this bit here. And it's a very simple formula. Area of this quantity is always going to be half r squared theta. Okay, that's it. There's not much to say here. And looking over here, and I've already dissected it, it's always good to always redraw the sector over here and just label the necessary parts, with this point here being the center. So we got the radius, which is 5, the angle, which is 0.7 radian, so theta is 0.7. Smash this in your calculator and you should get 8.75. Very easy, very easy. Next one, find the area of the flag to two decimal places. So the area of the flag is the whole shape, including the sector. So essentially, we just need to work out this area of the triangle right here. Okay, oops, area of the triangle. Now, to work on area of triangle, my best advice is for any given triangle shape, always you can find at least one angle with two lengths between it. So because we have 0.7 radians here, and if you think about, this is a straight line, and we know if it was in degrees, an angle around the straight line is always 180 degrees. In radians, it's always pi. So angle on a straight line always adds up to pi. That means if we've got 0.7 radians here, that means the angle over here is pi minus 0.7 radians, wherever that is. So that's the shape we want. So I'll pull that over here and just put the corresponding size, 7 and 5. And to work on area triangle, we always need two lengths between an angle. And we can use the formula half AB sine C. So A and B could be 5 or 7, any of them. And C, the angle between it is pi minus 0.7. And that's it. Just plug all this in the formula and you should get the area of the triangle. And that means the total area of the flag is the sum of the sector and that. So it's the sum of both areas here. If you add up these two figures here, you should get something like 20.02 centimeters squared. And make sure you keep it to 2 dp because that's what they want. Okay, so like I said, this is a very easy question. And lastly, find the length of the perimeter, xy of the flag. And that means work out the entire length around. So if we look at this, we've already got, if we look at the length, we're starting from X and we're going all the way to W, across the sector, the arc bit, and then Z to X. So we've already got 7, we've got 5. To work out the length of an arc, the formulas of length of an arc is always r theta, okay? And we can call this this segment Y. So let me just go ahead and delete this bit out. So this part we can call it Y. So we can say Y equals r theta. And then the length of X to Z, let's just call it X for now, yeah? So just keep this shape in mind and have a look what I did here. So where is it? In part C, so I split into two parts. So we've got the length X like I showed you, and the length and the arc length Y. So Y is r theta, which is easy to deduce. It'll just be, in other words, the radius, so 0.5 times 5 times 0.7. Oops, 5 times 0.7. And that should give us 3.5. Now, as for this one, we have to realize that we need to use the cosine rule. And the reason why is because with the cosine rule, you always need a single angle and 3 lengths you're working with. Every time you got that, it's 100% cosine rule. Otherwise, you would use the sine rule. So just a quick recap, the formula is given in the book, but otherwise it's a squared equals b squared plus c squared minus 2bc cos a. And a tip here, because you know there's a single angle here, otherwise capital A, if we call this angle here capital A, that means its corresponding opposite length is little a, meaning 5 and 7 are B or C. And that's it. So therefore, call A little a x and capital A pi minus 0.7, like I did here. And then replace B and C with 5 and 7. And then put all of this in the calculator, the right hand side, because you can do it at once. And then square root it to get x, and you're done. And you found the length of x. And therefore, just to recap, the perimeter is going to be the length around it. So it'll be 7 plus 5 plus the value of y, the arc length, plus x, what you just found. And therefore, let's have a look, and you should get this. Perimeter is over here. So 26.79. And that's it, guys. If that helped, let me know what you guys think about this question. I personally thought it was very easy and very straightforward, yeah? But yeah, otherwise, let's move on to the next one. Now, when you look at this head on, at least the first 3 parts are actually quite straightforward. When you look at the equation, you'll notice that it's actually an expanded form of the original circle equation. And if you're not familiar with the circle equation, it looks a bit like this. It's always x minus a all squared plus y minus b all squared equals the radius squared. And you got to note that a and b are actually the center of the circle. It's the coordinates for the center of the circle. So these are fixed values, yeah? That's one thing to know, they're fixed values. Now, looking back over here, you'll notice that this is, because this is an expanded form, the only way to get into the standard circle equation form is to always complete the square. You just have to do the reverse. So before you even answer A and B, it's best that you reverse the order of this using completing the square. So check it out. To get this format, what I did is just put the x's together and the y's together, and I use completing the square. If you're not familiar how to do that, the trick is that you always wrap this in a bracket, take off the square, and then half the coefficient of x. So 2 becomes 1. So a nice x minus 1 all squared, and then you minus it by the value squared, so the 1 squared. Same thing here. You wrap this out, you wrap the y's in a nice bracket, so y plus half of 14, which is 7, or squared, minus the value just halved, the value just obtained squared, so minus 7 squared. Now, the quick tip is that it doesn't matter what the sign here says, because the point is you just want to halve the actual absolute value bit squared, okay? You're not worried about the plus minus. It's always going to be minus that value squared. And that's really it. And when you do that, you'll notice that you got your x minus a and y minus b plot. So putting this together, you got all of this term plus all of this term. And then what I did, I just threw minus 1 squared and minus 7 squared to the right side, and I got plus 50. So just work this out, throw it to the right, and you're done. And therefore, comparing it to the standard format where you got center AB, so remember they use a minus sign here. So if it's minus A, that means the center is positive A, minus B is positive B. So that means you got center positive 1 and minus 7, okay? Whereas the radius is always square root, because this is r squared and radius is just r. So this is 50 equals r squared, therefore r is root 50 or 5 root 2. The question doesn't specify to simplify this bit, but you can keep either one solution. And by the way, this is for results of A and B, okay? Now, since we've done that, let's jump straight to part C then. So find the y coordinates of the points where the circle C crosses the y-axis. Now this is dead easy. Just think of the y-axis again if you forgot. And if the circle crosses it, let's say it crosses it like this for some reason, yeah? This means that at some point when it crossed it here, the x value was stuck at 0. So we know that the x coordinate is going to be 0 for both, okay? Anytime you cross the y-axis, x is 0. So what I did in part C, I just said crossing the y-axis implied x is 0. Then all you do is just plug in the value x equals 0 into the circle equation. So replace x with 0 to this, or even this one here. Both is fine. Actually, this would have been better. Solving it, and you should get, you know, just do your standard maths. Solving it, I used the circle equation formula. Square root this value. Minus 7, you should get either minus y equals minus 14 or 0. So the pair coordinates would be 0, negative 14, or 0, 0. Find an equation of the tangent to the circle over here at the point 2, 0. Okay, so to summarize this one nice and easy, because I've already drawn it, just imagine the circle equation, yeah? So let's just draw a nice circle, and let's label the center 1 minus 7, as we found earlier in part A. Now, the tangent line is going to be this red dotted line I drew over here, okay? Now, this red line over here represents the tangent equation where it hits exactly at 1 point, i.e. 2, 0. This is just a sketch, so this is not an accurate diagram. It's just an idea. Now, the only way to find the equation of this line from this information is to realize that we can firstly find the equation of the line from the center to 2, 0. And remember, and this is something important, that the tangent is always perpendicular to the radius. So when you find the equation of this line, the gradient of this line is perpendicular to the gradient of this line here. So that makes literally our equation simple. So my tip, find the gradient of line L1, i.e. find the change in y over change in x, which is over here. For example, minus 7 take away 0 over 1 minus 2, and that should give us 7. That's the gradient of L1. That means the gradient of the line we want, L2, is going to be the perpendicular gradient. So take the reciprocal 7, so 7 becomes 1 over 7, and then stick a minus sign, because remember, this is plus, it becomes minus. And there we go. So far, the equation of line 2 is y equals minus 1 over 7x plus c. So we're practically done. Now to find c, well, easy. Just plug in any known point on this line, and that is 2, 0. So we say at 2, 0, so when x is 2, y is 0, plug it in, you get 0 equals minus 2 sevenths plus c. Make c the subject, and you get 2 sevenths. And yeah, that's really it. So you found c, and now, yeah, we're done. So our final equation is y equals minus 1 over 7x plus 2 over 7. And just, you know, make it look nice. I just decided to times 7 and clear the fraction. And then rearrange it so it looks a bit like the form they want, which is what? Ax plus by plus c equals 0. So make everything equal 0. And yeah, we're all done. That's it. So like I said, this question too, I mean, if you understand how to do... if you understand the concept of tangent to a circle, it's always perpendicular to the equation from the radius. So that's my tip advice here. Always find the equation of this line, the gradient of this line, and just use a perpendicular gradient. And it helps if you sketch. If you sketch, it makes the whole problem easy. But anyway, guys, if you enjoyed this question too, give me a like, share, subscribe, you know, the usual things I've been saying. But otherwise, let's move on. Now, this question, in my opinion, is the easiest question on the paper. Well, I can't lie. So far, the questions haven't been too terrible. Now, how do we do this? So, my tip for any geometric series is to always write down all the formulas you know. I mean, you're given some of this in the booklet, and you can check on my description because I got the formula PDF, the formula booklet over there attached to the description. And all you have to do is just write them down here and just realize that A is the first term, R is the common ratio, and of course N is, you know, your nth term, your nth value, wherever you are. Now you got the position term here, you got the sum of the first n terms, and you got the sum to infinite number n terms. So in other words, sum to infinity, where n is 99999 or so on. Okay, so what do we want? So it tells us that the geometric series with common ratio is r equals minus 0.7. So that's good. So we can literally plug in right here to all of them. And the sum to infinity is 10,000. Perfect. So this means this third equation, we have 10,000 equals a times, or a over 1 minus 0.9. In other words, over here. Just collect it nicely. And all of that equals 10,000. So instantly, just timesing 1 plus 0.9 across, you get a equals 19,000. So that's easy. So for the series, find the first term. Oh yeah, so the first term is 19,000. Now find the fifth term. So the fifth term is used using the UN formula. So you're literally just finding U5. So you can say U5 equals A times R to the power 5 minus 1. And I put it over here. So replacing A and R with what you know, A is 19,000, R is minus 0.9. And all of this A value to the power of 5 minus 1 over 4, you should get this value here, 12,465.9. Easy. Like I said, the easy question. And last one, find the sum of the first 12 terms, giving you this answer to the nearest integer. So this is easy. The only thing where you could actually drop marks if you just don't round it properly to the nearest integer. So the sum of the first 12 terms is literally S12. So again, this question is not really like difficult. It's very basic compared to what you might have seen in the past. Not really inspired, which is, you know, I'm not going to complain. So to find S12, I did over here. It's just the same formula, A times 1 minus R to the 12. You have A, you have R. Just make sure you put R in a nice bracket so you don't make mistakes. Put in the calculator, you should get some decimal and round up 7,176. Easy. Can't say much, and that's literally 6 done. So for these type of problems, every time you got a subject term as a power of the usual equation, in other words, you got x and y as a power, you could usually just solve this easily using logs. In other words, you could take logs and pretty much get this done. Now, the way I did it here, and just to do this fast, I took logs on both sides, and the unique feature about logs is that you can, of course, use this kind of property here, where you have, let's say, log a to the power n, and what this really means is that the n will just drop in front of the log, so it looks like this, n times log a. So that's the unique feature about logs, and it helps us solve many more complicated problems, especially with powers. So looking at the solution, so with y minus 1, you could just essentially drop in front of the log, so it'll be y minus 1 times log 1.01, and log 500 is the same, and then just rearrange to make y the subject. So what I did, I just divided log 1.01 across, and then added 1, and then I got something like this. You could just smash this in the calculator and get the answer, but if you're not sure how to type the log button, you could use the alternative and use ln 500 over ln 1.01, or equivalently, you could just use log 10 500. So log 10 500 over log 10 1.01 plus 1 to give us the answer. But yeah, just be careful how you input this properly. It's best to put this if you see it exactly as it is. That's all. Okay, part 2. So given that we have a typical log equation, which is in terms of base log 4, show that all of this can be written as a quadratic equation and hence solve that equation, okay, using, you know, usual quadratic formula. Okay, so first things first, let's just write this down over here nicely, and that's what I did over here. Now the first thing you want to notice over here is that when you're working with logs, get rid of any number in front of the logs. That's the first step. So this 2 here needs to go. Using the power of logs, when you have a number in front, it goes straight over here. So that's why we got a 2 over here. Next rule, since you got 2 terms in terms of log 4, my advice is to throw them all on the same side. So I would move the right hand log to the left side, yeah, so subtract it. And then using the rule, when you're subtracting logs, for example, log a minus log b, you always get log a over b. So essentially, you're going to get 3x plus 5 squared over 3x plus 8. So that this part here is essentially a over b. Okay, so this bit is easy. Once you're here now, this is where you really have to just notice that we have to get rid of the log entirely. Now to get rid of the log, we can use something known as the ladder rule. And that is, if we fix some pivot n, so in other words, if we call all of this n and just lock it here for a second, we can use the staircase method and just raise a up once and b up as well. So it would be n equals this a going up and this b going up. So like a ladder, so a to the power b. So looking at this number, if we fix this entire term here, we just bring the 4 up and the 1 up. So it'll be all of this equals 4 to the power 1. So yeah, this is just a nice little rule. I recommend you guys really memorize the ladder rule and of course the general log a minus or plus b. If you had to just for a second add them up, this is the same as multiplying, so it'd be log a times b. Okay, anyway, getting back to the question, so now we're here. This is easy to solve. So all we want to do now is just clear the fraction, so times 3x plus a across, so it'll be 4 times the right hand side, and then you're left with the squared bracket. Expand the squared bracket, so remember this is 3x plus 5 times 3x plus 5. And if you expand it correctly, you know, using the FOIL method, you should get something like this on the left. And this is easy to expand to get down the right. Now just subtract 12x and 32 to the left side or across, and you eventually get what they want, which is 9x squared plus 18x minus 7. And double checking that, you should get that. Yes, you should. So quite straightforward. Now finally, you know what to do here. This is a quadratic equation, so let 9 equals a, 18 be b, and c is minus 7. Smash into the standard quadratic formula, and you should get 2 solutions, a third or minus 7 and 3. Now the reason why I said this is the only solution is because we have to be very careful here. So looking at the equation, we have like a fixed domain, which is over here. This tells us that x needs to be greater than minus 5 over 3. Like the logic behind this is that we cannot have a negative value inside the logs, just like square root functions. This means that the minimum value has to be, for this to actually work, has to be bigger than 0. Okay, same with this one here. So that's why they put this, it imposes limit. And now looking at this value, for the x value is greater than minus 5 thirds, well, minus 7 thirds is slightly less. So that's why we only have 1/3. And that's it. That's literally all of this done. So in this question, solutions based entirely on graphical or numerical methods are not acceptable. In other words, we have to solve this using charts or graphs or purely non-calculator based work. Okay, anyway, let's have a look at this. So solve for the given angle range, which is in degrees by the way, so set your calculator into degree mode, for the given equation, which is 4 cos x plus 70 equals 3. Now to do this one, firstly, let's just make cos and everything inside the subject, so just divide 4 across. So I got something like this. I got cos x plus 70 equals 3/4, and then finally cos inverse to get a solution. Now to solve for x, you can easily get one solution now. However, if you notice here, and if you subtract 70, you're going to get a negative answer. And the problem with this result is that it does not fit the valid solution of x being bigger than 0 and less than 360. The value of x here, once you solve it, will be outside the interval. Now to get all other solutions, we have to use something known as a cast diagram, okay? So before I even take that step and find x, let's just work with 41.4. Every time you cos inverses, yeah, give this another name, like, I don't know, y, yeah? Like y. So therefore y equals 41.4. And now, to use the cast diagram, so you write C-A-S-T. When you're working with cos, we're going to use C. Because the answer is positive and we work to positive values, we're going to put an angle here for C and a line here for A. And call these both angle y. Now A stands for all, so this means always positive, and C here stands for cos because we're working with cos, and again S and T are sine and tan. Now to find all solutions, all you simply have to do is just realize that this is the pivot, so this is 0 degrees or 360 and so on, and then we just travel upwards. So let's do this as we go. So to get the first pair of solutions, we can see that we can go this way around to get, and this is an angle of y of 41.4, or we can go down here, and this is an angle going downwards of minus 41.4. Because remember, when you go below 0, it's negative. When you go upwards, it's positive. So think of it that way, yeah? So this way is in the positive direction, and this way is in the negative direction. Because all our solutions are positive, we need to always go around, yeah? So to get additional solutions, all we do is start here and then we do a full circle until we hit the next blue line, which is here. And you'll notice that it's almost a complete circle, but just y degrees less. So in other words, 360 less 41.4. And then if you do another one, so let me change the color pen. If we go all the way around, you can see you can go past 360 and then hit the next blue line, which is a whole circle plus y, or 360 plus 41.4. And then you'll realize that you can do this multiple times. So if you do another solution, say let's do it twice here. Let's go past the next line. So if we go past the first blue lines and then do another loop, you'll see that we've done almost 2 circles, but y degrees less. So that'll be 720 minus 41.4. And again, 720 plus. So you can see it's always going to be in series of 360 times 360s or 720s and so on. Anyway, so that's all the possible solutions for y. So we have a bunch of solutions. However, to find x, now we need to use all of this and subtract them all by 70. So my guess is always start from the top. So let's use the plus value. So 41.4 minus 70 will give us a negative. If we start with minus, again, that's negative. So this first solution is invalid. So using 360. So I'm going to use the plus first, yeah? So if you do 360 plus 41.4 minus 70, you should get an x value of 331. And yes, that's within the 0 to 360. If I use the negative value here, you do 360 minus 41.4 and then minus 70 to find x, and you should get 248.6. Now, if you do the same for 720, you'll realize you get solutions bigger than 360. So the only 2 solutions are these, and that's it. So that's literally how you use a cast diagram in a very straightforward manner. Okay, now let's look at part 2. So part 2. So find for theta between 0 and 2 pi. So now we're working in radians. Yeah. So again, shift your calculator into radian mode. Okay, because you're working in pi forms. All the solutions of the given trig equation. Now, one thing I want to note here as well. So when you're working with cos squared or sine squared and so on, have a look at the entire equation and see what you can find more of. In this one, you can see that this is mainly dominated by sines. Now one cool trick about sine squared and cos squared is that you can use the standard trig formula, which is sine squared theta plus cos squared theta equals 1. And my tip is to always rewrite all of this in either fully sines or fully cos. Because you've got more sines, it's advisable to change cos squared here into something with sine squared. So looking at the general, popular equation, make cos squared the subject here, so you should get cos squared theta equals 1 minus sine squared theta. So just rearrange. And then substitute all of this one for cos squared. So anyway, let's have a look, yeah? So for part 2, it's over here. So again, notice that, make cos squared subject and then replace cos squared theta here, so you get 1 minus sine squared. Expand the bracket, so you get 6 minus 6 sine squared theta. And then realize now that you can actually form some kind of quadratic equation, yeah? So what I did here, I just pretty much added 6 sine squared. I did 6 take away 5, which is 1, and then actually I left it there. And then plus it across. No way, 6 take away 5 is 1, then subtract because you get minus 1, and you still got sine theta. So in other words, throw everything here on the right hand side, and you should get something like this, a nice quadratic equation. And now, from here, just say, to solve this directly, just think of this as, I don't know, 12 y squared plus y minus 1. So think of this one as y. Using the standard formula, replace your a, b, and c values. So in this case, a here would be 12, so a is 12, b here is 1, and c here is minus 1. Okay, and then plug into the formula and you should get something like this. So sine theta is a quarter, or sine theta is minus a third. Now, yeah, and then when you sine inverse both of these, you should get 2 solutions. Now, what you could do here, you could use a cast diagram, but I'm going to go ahead and use the actual sine wave, because the reason why is that when you have a negative solutions, you have to realize that using the cast diagram, we cannot use S anymore. We'd have to use the other layers, T and C. And to avoid that confusion, I think it's best to use the sine, the actual wave. Okay? And that's it. And now all you do is literally just draw a line cutting through quarter here, which is 1 over 4. And you draw another line cutting through minus a third, which is over here. And just draw it all the way across until you cut up to 2 pi degrees. So here's 2 pi. Here's pi, and then you just draw lines. Now, to find valid solutions, you can see that up to a quarter, we had 0.253. This means that at this point, the solution was 2.53. And same for this one. It says theta was minus 0.34. So in other words, minus 0.34 is on the left side. This part here was minus 0.34. This means on the right hand side, if you continue through this line, you'll find that this solution here would be pi plus 0.34. And if you carry on across, and here if this is 2 pi, this is 0.34 less than 2 pi, so 2 pi minus 0.34. So these are a couple solutions you can use. For the quarter value, again, the quarter value is 0.253, and if pi is over here, if you just draw a little dot line from here, you realize that this value is just a bit less than pi, so it's pi minus 0.253. And if you were to carry on, I mean, you won't get another solution because then this one cuts over here. So your next solution would be like something like 2 pi plus, and then that would be out of the range. So yeah, so your final solutions here would therefore be this solution here because it's in the range, not this one. This solution here because it's in the range, this solution, and finally this solution. And oh yeah, sorry. And here is your final solution. So smashing this in the calculator, you got 2.53 there. Pi minus 0.53 should give us 2.89. Pi plus 0.34 should give us 3.48. And finally, 2 pi minus this value should give us 5.94. Done. And yeah, keep all your answers to 3 significant figures because that's what they wanted, yeah? And that's all. So yeah, if you enjoyed this video, give me a like, subscribe, share with your friends. Otherwise, catch you in the final one. Ciao. And here we are, guys, the final question, so number 9. Now this one in particular was a lot easier than last year's paper for 2017, okay? This one is actually straightforward because you just require a rectangle and integrate underneath the curve to find the area R. Anyway, let's have a look, yeah? And oh yeah, a few things I noted. So I call this TP, so I call this one the turning point because this is where it turns. And to find a coordinate of the turning point, remember that this is when the gradient is flat. So that means when you use dy dx, it equals 0 because this means it's a 0 gradient, okay? And that's it. Let's have a look. So now this figure here shows a sketch of part of a curve with a given equation, okay? My tip here right now is to expand the bracket, yeah? To get something like this. And if you're not sure how to expand it properly, you got 7x squared times root x. And root x is the same as x to the power of half. So 7x squared times x to the power of half, you add the power. So you get 2 plus half, which is, and I just wrote it simply as 2.5. Because this is C2, not C1, always write things, especially powers, if they're in decimal, preferably in decimal form. Because when you integrate, it's easier to not mess it up. Okay? And differentiate is easier to not mess it up. Now, let's keep going. So the curve has a turning point at point A, so that's why I call it TP. And we know that by differentiating to get the coordinates. And then so on. So A, using calculus, find the coordinates of the point A. Now straightforward. In other words, we got the curve here. Here's at this point. Let's dy over dx this equation right here. So when I did that, I got 70x minus 35x to the power 1.5. Quick tip here. All you do is drop the powers down. So it becomes 70 and subtract it by 1. Drop 2.5 down. So 2.5 times 14 gave us 35. Subtract by 1, you get 1.5. Easy step. And now because it's a turning point, you can set this equation to 0. So then you can have 70x equals 35x power 1.5. And then just make x a subject. So divide 35 across, and all of this here becomes 2. Divide x across, so you get x to power 1.5 over x. And remember, this is x power 1. So to do this, when you're dividing terms, you subtract the powers. So all of this becomes x to the power of half, or 0.5. And lastly, to get x, you just square both sides. So then you get x equals 4. Or you could use the cube root button and change the 3 into a half. So it looks something like this. So instead of 3 here, cross out on the calculator and write 0.5. So then you just change that to 0.5 or half. And this again will give you 4. So that's if you're not too sure how to work with these. Okay, so that's the easy bit. So again, we're trying to find the coordinates A. So now we got the x value. All you want to do is plug the x value back into either the y equation to get the y coordinates or over here. Both is fine. And when you do that, you should get 112. So this means that this coordinate here is 4 and 112. Okay, not bad. Oh yeah, so just to be clear, so it has a height of 112, and we can see now, just to expand this one a bit, oh wow, that's terrible. It has a width of 4, so 4 to b. So now we need to know what b is later. So let's have a look. The curve crosses the x-axis at the point B. So like I said, this paper is easy. This question is easy. So if it crosses the x-axis at point B, this means that it has a y value of 0, which is kind of clear because it's on the ground. So now you just plug in y equals 0 to this equation here, and then you solve for x. And when I did that, what did I do? So I wrote that down. So always make your assumption. So 0 equals this. And then, you know what? You're right. You know, use the original equation because it's already factorized. So you can say, therefore, 0 equals 7x squared or 0 equals 5 minus 2 root x. And solving both, well, that left side is easy. You just divide by 7, square root, you still get 0. But then that's useless because x equals 0 is the point where it crosses over here. And we don't need that. We want b. So likely the solution will come from the second pair. So yeah. So plus 2 root x across, divide by 2, and then square both sides. Your x coordinate should be 25 over 4. And that's it. B is 25 over 4. So yes, I mean, I'll be honest, there's not really much hard things here. It's only 2 marks, that's 5 marks. These are easy marks, okay? Now, finally, here comes the big boss. So the finite region R, which is over here, blah, blah, is bounded by the curve, the line through A, parallel to x-axis, and the line through B. You know, let's just go ahead and update this. So we had a b coordinate of 25 over 4. So that's this coordinate here. Now, in other words, it just wants us to find the area of R. So let's look at this one more time. If you've got the region R here, you can clearly see that there seems to be like, to get this shape, you can see that there's a rectangle here. Now, the area of this part here is only found by using integration, yeah? Because remember, the integration is used to find the area under a curve, not above it, under it. So if you integrate from, let's say, 4 to 25 over 4, so this entire width, you're technically integrating the area underneath it, below this curve, up until here, so all this purple region. So you can say, okay, if we do the area of a rectangle, which has a width of whatever the difference between 4 and 25 over 4 is, and a height of, what is it, 112, and subtract it from the purple region, you got your answer for R. So set up like this. So I wrote it here. So you can say the area, so the entire rectangle is 2 so yeah, the difference between 4 and 20 over 4 is 2.25, times it by 112, and you get 252. So that's the whole area, the whole block, A plus R. And then subtract the area A, which is integration, and you just integrate from the limits 4 to 25 over 4. So, and that should be like this. And then here's our curve, as we found earlier, and that's it, we're done. Just integrate, plug in the x values, and you solved it. So integrating 35x squared, you just raise the power by 1, so it becomes 3 over 3. Raise 2.5 by 1, so 3.5 over 3.5. And then just plug in firstly, replace all the x values here with 25 over 4 to get roughly 406.9 ... And then replace every value here with 4 to get about 704 over 3. Okay, so and then solve this, and then when you solve this, do 252 minus your result, and you should get an area or region of R of about 79.77 units squared. And that's it, all solved. That's literally integration in a nutshell, and all of it done. And just to be clear, they wanted in 2 dp, 2 decimal places. So yeah, if you guys enjoyed this video, and I mean this whole paper as a whole, you know, give me a like, share with your friends, and you know, any positive feedback, comments, and any particular questions, give me a shout. I'm here. I'm gonna be here every single year doing this over and over, and probably until the day I die. Who knows? But yeah, I hope you guys enjoyed it, and have a great day. Ciao.